Hi everyone and welcome to the learning curve. In this video I will be looking at how to solve logarithmic equations. The first one we have here is that the log of x minus 3 base 2 is equal to 5. The first thing to do to solve a logarithmic equation like this is to express it in exponential form and then solve for x. In general, when we are trying to solve logarithmic equations, we first try to express them in a condensed form and then express them in exponential form and solve. Because this logarithmic function is already in a condensed form, we can go straight ahead and express it in the exponential form by raising the base of the log to the power of the term on the other side of the equation. This will be 2 to the 5th power, equal to the expression that we're taking the log of, which is x minus 3. So all we're going to do here is to evaluate 2 to the 5th power, which is 32. So 32 is equal to x minus 3. So that we can now solve for x by adding 3 to both sides of the equation. So that here we would get 32 plus 3. So x here is equal to 35. In the second equation, this one is a little bit more involved. So when you're solving logarithmic equations, as I indicated, you first condense the logarithmic equation and then solve by expressing it in exponential form and solving from there. So to condense this log function, we're going to express it as log of x squared. That is, we bring the 2 up, the 2 in front of the log, we bring it up to be a power of x. So this 2 goes up to be a power, and when we're condensing, powers go up. So coefficients of logs go up to become powers of whatever we're taking the log of. So this is equal to the log of 2. Since we're adding here, this is log of 2 plus the log of x plus 4. So to condense this addition, we'll write the log once and multiply the terms that we're taking the log of. So that will be 2 times x plus 4. And that's how we condense the log of a summation, by writing the log once and just multiplying the terms that we're taking the log of. So when we simplify this a little further, we get the log of x squared equal to, and this would be the log of 2 multiplied by x, which is 2x, and 2 multiplied by 4, which is 8. So this becomes the log of 2x plus 8. Now, we are at a point where we have an expression where we're taking the log of both sides, an equation where we're taking the log of both sides. Because we're taking the log of both sides and the bases are the same, when the base of the log is not stated, it is 10. So these are really log base 10. If the bases are the same and we're taking the log of terms on both sides of the equation, we can basically just drop the log, which we will do in this case. So we drop the log and say x squared is equal to 2x plus 8. Now we recognize that we have x squared here and we have a bx and a constant. So we can express this as in quadratic form. So expressing this in quadratic form, we'll get x squared minus 2x minus 8. The 2x and the positive 8 will become negative on the left-hand side of the equation by inverse operation, equals 0, because nothing will be left on that side of the equation. Now we realize that we now have a quadratic in standard form, so we're going to factorize this quadratic by writing down the values of a, which is the coefficient of x squared, that's an invisible one, b, which would be the coefficient of x, that's negative 2, and the constant c, which is equal to negative 8. The next thing we're going to do here is that we're going to multiply to factorize this quadratic, which is how we're going to solve for x. Our aim here is to solve for x. So to solve for x here, we're going to factorize the quadratic equation by multiplying here a by c When we multiply a by c, that's 1 multiplied by negative 8. 1 multiplied by negative 8, which is negative 8. And then we're going to try and find two numbers that we can multiply to give us AC, which is negative 8, and also add to give us B. So what two numbers can be multiplied to give us negative 8 and add to give us, and those two numbers when added will give us B, which is negative 2. And we realize that that would simply be negative 4 and 2. When I multiply negative 4 by 2, I get negative 8. And when I add negative 4 and 2, I will get negative 2. So that works. So now I'll rewrite the quadratic as x squared right here. I'll rewrite the quadratic as x squared minus 4x, because the terms have to be expressed in terms of x since we are replacing the middle term bx. So minus 4x plus 2x, which are these numbers here, multiplied by x, take away the 8. That is already in the function. What we're going to do now is that we're going to basically just organize these into pairs to make the solution process very simple. The purpose of organizing these into pairs is now to allow us to do factoring. So I'm going to factor out x, we're going to find the highest common factor in each pair. In the first pair here, which is x squared minus 4x, the highest common factor is x. So I factor out x. Then I say x goes into x squared x times, and x goes into negative 4x negative 4 times. Then what is the highest common factor between positive 2x and negative 8? What we realize here is that we can factor out positive 2. That's the highest common factor. So positive 2 divided into positive 2x will give us x, and positive 2 divided into negative 8 will give us negative 4. So what we realize here is that the terms inside the bracket are the same, so that the factors of this quadratic would be x minus 4 into, and I pair the outer terms here, x and positive 2, so it will be x plus 4 into x minus 4 into x plus 2. These are the factors of the quadratic, and therefore the solution for this logarithmic function would simply be found by setting these factors equal to 0 and solving for x. So if x minus 4 equals 0, then x is equal to 0 plus 4, which is 4. And ax, so this is the factor here, and the other factor is x plus 2, which we're also going to set equal to 0. So here x plus 2 is equal to 0. So x would be equal to negative 2. So those are the solutions for this logarithmic function, x equals 4 and x equals negative 2. Well, let's look at this third problem. As I indicated before, the first thing you want to do when you're solving a logarithmic equation, if it's not already condensed, is to condense it. If we're adding, we will convert to a multiplication, and the bases are the same. If we're adding and the bases are the same, we will write the log once and just multiply the terms that we're taking the log of. That is what we would do to condense. If it was a division, if it was a minus, if it was that we're subtracting two logs with the same base, then we would divide the terms that we're taking the log of, writing the log once when we're condensing. So this would become log of x divided by x plus 8. So log of x divided by x plus 8. Yes, log of x divided by x plus 8. And the base of this log is 3. Okay, so log of x divided by x plus 8, base of the log is 3. So here we go. That's log base 3 x upon x plus 8 equal to 2. So the next thing to do is to express this log, now that it is in a simplified form, a condensed form in other words. We're now going to express it in exponential form by raising the base of the log to the power of the term on the other side of the equation. So base of the log is 3 raised to the power of the constant 2. And and we set that equal to whatever we're taking the log of, which is x upon x plus 8. Now 3 squared is going to give me 9. So 9 is equal to x upon x plus 8. Now since we're solving for x, we need to try and get rid of the denominator here. And to get rid of a denominator in any fraction, we multiply by that fraction, which is the inverse operation, because we multiply by the denominator of that fraction. So we're dividing by x plus 8, so by inverse operation, to get rid of that x plus 8, we will multiply the right side here by x plus 8. What you do to one side of an equation, you have to also do to the other side. So I'll multiply the left-hand side of the equation by x plus 8 as well. Now x plus 8 here will cancel x plus 8, so that I would simply be left with x equal, and let's expand the bracket here, 9 multiplied by x here would give us 9x, and 9/8 will give me 72. So I distributed the 9 throughout the bracket. So therefore, what we're simply left with here is 9x. I'm going to put the x's together on the same side, preferably where it would be positive, which is on the left side. So if the x on the right hand side goes to the left hand side, it will become a negative by inverse operation. And we're going to put the constant to the other side of the equation, so we're grouping like terms. The constant here of positive 72 on the left side of the equation will be negative 72 on the right side of the equation by inverse operation. So here we will get 9x minus 1x is 8x equal negative 72. So since 8 is multiplied by x and we want to get x on its own, by inverse operation we will divide by 8 on the left hand side of the equation, and what you do to one side of an equation you also have to do to the other side. So therefore I get 8 divided by 8 here will just leave me with x, and of course we have negative 72 divided by 8, which is just going to give us negative 9, and that is our answer, negative 9. So we've looked at solving different types of logarithmic problems here. The basic principle remains the same. I hope you found this video to be extremely beneficial in furthering your understanding of logarithmic equations and how to solve them. Thank you for your time. Remember to like, share, and subscribe as we continue our indulgence in the world of mathematics. Thank you.